How you going, Year 9? Welcome back to another video. Today we are looking at trigonometric ratios, okay? As we talked about how we're starting this trigonometry unit, trigonometric ratios. Basically, a triangle has three sides. I don't know if that's something you knew before or not, but the relationship that that side has with a particular angle in that triangle has a particular word. We're going to be learning about how the ratio between those sides is actually common given a constant angle size, okay? And then we can use that for all sorts of things using triangles. Okay, the first thing we need to know is the relationship between each of the sides to a particular angle in the triangle. Now, we're looking at specifically right-angled triangles this term. It makes it a bit simpler. We will look at non-right-angled triangles next year. We might even do a little bit of that this term if we have time. But in a right-angled triangle, you always have a longest side, which is called the hypotenuse, okay? That's opposite the right angle. Okay, now we have two other angles in that triangle. Depending on which angle we look at, the relationship with that angle in the sides, or which sides have a particular relationship, will be different. So we have the opposite side, which is always across from that angle. Okay, if you think about the house that's opposite you on the other side of the street, okay, you look across at it. We can see here we've got our angle theta. Okay, theta is just a Greek letter. Because a lot of this geometry stuff comes from ancient Greece, okay, and they started using things like theta and pi, which are all Greek letters to indicate certain things. So theta is often used for an angle, and it's just like a little sort of, you start with the tail and then you do a little loop-de-loop, and it becomes sort of like a circle with a tail in front. Theta is often, we can see, is down here at the bottom right. The opposite side is across from it, and then the adjacent side is next to it. Okay, adjacent means next to. So if your next door neighbors, okay, that are on the same side of the street, are adjacent to your house. Okay, so if you need to remember that, I often think about the street, whether the house is opposite on the other side, or if it's adjacent next to you. However, if we move that angle that we're looking at, then these things change. So firstly, the hypotenuse does not change. It's always opposite the right angle, and then the adjacent side is the side that's next to it that's not the hypotenuse. So you could say technically that the hypotenuse is adjacent to that angle, but it has a special name because it's opposite the right angle. So the other side that's next to that angle is the adjacent one. Okay, and then down here, this will be the opposite side from that angle. Okay, so you see it's a matter of perspective. Which angle are you looking at determines which side is adjacent and which side is opposite. The hypotenuse, though, is always opposite the right angle. Okay, so let's do an example here. Name the side that's the hypotenuse. Okay, that's going to be PR. Okay, the side that's opposite P is going to be QR. Okay, it's across from P. The side adjacent to angle P, again, we're not going to use the hypotenuse, so we're going to use the non-hypotenuse adjacent side, which is PQ. Okay, side opposite angle R is going to be PQ. Okay, the side adjacent to angle R, again, not the hypotenuse, is going to be QR. Okay, and you can see there's this relationship. The side that's adjacent to one angle is the side that's opposite to the other angle. Okay, makes sense. All right, now we're looking at ratios. A ratio is just when you divide a quantity by another. So these particular ratios are going to become important in a moment. So we've got to find the opposite over adjacent. So we're looking at this angle theta. The opposite is Q. It goes on top, and then divided by the adjacent, which is P. That goes on bottom. Opposite over hypotenuse. Okay, so the opposite side is still Q. But this time the hypotenuse is R, and then adjacent, okay, which is P, and the hypotenuse is P over R. Okay, so we're just doing that same process, except we're forming a ratio. We've got to make sure that we've got the right side on top and the right side on the bottom. Okay, now finally, we get to a little fun one. I'm just going to create a little bit more space here. So we have three key trigonometric ratios that use these different things: opposite, adjacent, opposite, hypotenuse. And we're going to remember them using this little acronym. You may have heard it before, SOHCAHTOA. Okay, our three ratios are sine, okay, which is sometimes spelled as S-I-N-E, okay, but simplified as S-I-N, but we pronounce it sine, not sin, pronounce it sine. And then there's the cosine, which is often abbreviated as cos, which is basically the opposite of sine, cosine. But we just say cos, and then the tangent ratio, which we're just going to abbreviate as tan. So sine, cos, tan is how we say those. Now, the sine, the ratio of sine is the opposite over the hypotenuse. Okay, so S-O-H, sine equals opposite over hypotenuse. Okay, so it's always a ratio and it's always an equals. So sine theta, I should say, of an angle, sine angle equals opposite over hypotenuse. Okay, ca stands for cos and then adjacent and hypotenuse. Okay, so cos theta equals adjacent divided by hypotenuse. And it's always top first and bottom second. So if you remember, so the O is before the H, so the O goes on top, the H goes on bottom. And then finally, tan is opposite over adjacent. So tan theta equals opposite over adjacent. Okay, SOHCAHTOA. We always get a trigonometric ratio of the angle equals and then some kind of ratio of the sides. So in the triangle ABC, find the expressions for tan theta, cos theta, and sine theta. Okay, so here's our theta. And for tan, TOA, it's going to be tan theta equals, and then opposite, which is BC, divided by adjacent, which is AC. Okay, for cos theta, we get an equation, and so AH, so adjacent, which is AC, over the hypotenuse, which is AB, and then sine theta is opposite over hypotenuse. So it's going to be BC over AB. Okay, we see these three key ratios between these sides here. Sine, cos, tan. SOHCAHTOA is the way that we're going to remember how to write these equations. Okay, and which one goes on top of the ratio and which one goes on the bottom. All right, good luck with the work today. See ya in the next video.